All right, so we went through the group data yesterday. So today we're going to be talking about percentiles and box and whisker plots. So everything in this chapter is talking about the measures of variation and central tendency, and we're looking at how we can assess an expected value and then how the other values kind of deviate from that mean and how they're clumped together and what sort of patterns we can see. So when we have distributions that are skewed or bimodal, or they have just extreme values in general, we can get a better summary of the numbers by finding out their relative position rather than the exact values. If I were to look at some test scores and I see that the average was an 80, I would think that that would be pretty good. I would be happy with that. An 80 is not a bad average. But then if I were to look at the breakdown of how people did, and I see a big chunk of people were in the 60s, and a big chunk of people were in the 90s, and it just so happened that when we averaged those out with a couple sprinkled in between, it came out to an 80. So if my class averaged an 80, I would think that they were pretty proficient with the material, and I would feel comfortable moving on. If I looked at the spread of the data, and I saw that the majority of, or rather most of the tests were clumped in either the beginning or the end of the scale, I would have to stop the class and be like, all right, half the class gets it, they understood the material, they're able to reproduce what I was trying to teach, and they seem to understand the content. Great. The other half of the class is not in the same boat, so we need to come up with an intervention. I would not know that if I was only talking about the mean. If I only recognized the mean or the median or the mode, I would not be able to make that sort of assessment. The fact that I can see the spread of data would allow me to make that judgment call. It also, looking at the spread, it also allows you to understand not necessarily how good or bad your score is, but how your score compares to those around you. So let's say the median score was an 80. So if the median score was an 80, that means that half the scores are worse than an 80 or better than an 80, or they could be equal to an 82. So if you scored an 80% on that test, and I said, hey, you're in the 50th percentile, what that would mean is that you scored the same or better than 50% of your classmates. So even though you got the 80 and you got the average and you're like, oh, I'm right in the middle. Everyone else got around an 80. And then I told you that you're in the 50th percentile, you would then look around again and say, half the people in here did better than me. Even though I have the average score, half the people are in a better standing than I am. I don't know about you, but when I think about averages, I would not think that half the people would be better than me if I am the average score. So again, that's where the percentiles can just put things into perspective. They actually use percentiles too to measure other areas of growth. So a couple examples. One is when I took my test to become a teacher, I had to go through 4 years of college. And after the second year, so going into my third year, I had to take a test called the Praxis, Praxis. And the Praxis was basically what I felt was an easier SAT. I took it. It wasn't a big deal. I had to do it on a Saturday morning, kind of like the SAT. Started at 7:30, and it was like a 5-hour long test. They had a math portion, a reading, a writing, a science, and something else. And so you just had to sit there and take this test. It was extremely boring. I remember I just tried to race people when we were taking it. I'd take it, look around, see if I was the first one, second one done. Got the scores back. They were great. They were fine. Not a big deal. But then with the Praxis 2, that was a test I had to take that was specifically in my content, and it had to be taken in order to be getting the title of a highly qualified teacher. So if I passed this test, even though I had no teaching experience, I was then considered a highly qualified teacher. Now, the way the Praxis 2 worked is that it didn't matter what I scored. it mattered what everyone else was scoring. And in comparison to all of those scores, only the top blank percent of the people passed the Praxis 2. And so I took it and I did well on the first part. It was a 3-hour computation test. I just finished taking Calculus 3 in college, so like I was pretty well prepared for the math portion, and I tested above average, which was great. But I felt really good before that test score because during one of our breaks, I was in the bathroom and there was some guy freaking out. It was his like 7th time taking the test, and he swore that they put problems on the test that were impossible to answer so that they would skew results. So I felt pretty good leaving the bathroom because I was like, all right, at least this guy's going to score lower than me. So that was fine. I understood that I was above average, blah, blah. Now, the thing that where this really stood out is the second part of the Praxis 2 was a proof-based test. You had 1 hour to answer 4 questions. And they were pretty tough proofs. And so I remember I did the first proof. I felt really good about it. I knew I got the right answer. And then our person that was administering the test notified us that we had 15 minutes left. 15 minutes. So in 15 minutes, I just drew a sketch and started the other 3 proofs. And I was like, crap, I just failed this. Got those reports back, also above average. Blew my mind. How is it that I should have gotten probably a 30 or a 40% on that test, and instead I'm scoring above average? What that means is whoever the crop of people that are coming in, whatever knowledge they have, they probably all have the same knowledge. So depending on how they all test, you're just going to take the top ones of those people, pass them, and then everyone else can just retake the test. It doesn't matter if they're actually as smart as the people as the year before or the year before that. That doesn't matter at all. It's just in perspective of who you're taking the test with. So that is a direct impact of how percentiles would affect, because I could be of a certain level of intelligence, and 10 years from now, everyone could be so much smarter than I was then, but they may not pass the Praxis 2 because the people around them are also smarter than the group I was around 10 years ago, something like that. Another example where percentiles are used is the measurement of children. When they are born, you are weighed, you are measured, and they check the circumference of your head. Those are the 3 measurements, and every 6 months when you go back to the doctor's appointment, and then every year when you go back, you get growth projections. So if you have a certain weight and a certain height and a certain head circumference, they can predict what your height and weight will be when you're older. And so if you are of a lower percentile, then they might start implementing, maybe you should take some Pediasure, or maybe you need to be changing your diet, maybe you need to be doing this or that. And so they can start to judge things at a younger age. You can also tell some diseases based off of the proportions and the growth or lack of growth of certain areas. So they use those to predict for the future, but those percentiles are based around the same number, the same kids that are the kids that are born around the same time that you are. So when my son was born, he was weighed, measured, and his head was measured. And he was in like the 0th percentile for weight, he was in the 5th percentile for height, and he was in the 99th percentile for head circumference. So he was a tiny kid with a big head. As he's gotten older, the proportions have gotten closer and closer. He turned 4 back in July. He's now in the 75th percentile for height, the 70th percentile for weight, and the 85th percentile for head circumference. So he's still got a big head. But he's starting to become more proportionate. But again, all of that is just based off of kids that were born around the same time that he was. So if I were to look at my scores as a baby versus his, those percentiles may not line up, because based off of genetics and people born around the same time in the same location could alter how those work. So enough of those tangents. In a nutshell, percentiles are useful, but they're useful to judge where you are in respect to everyone else, not necessarily the quality of your score. How to find percentiles. So we can do percentiles by hand, and we can do percentiles using Google Sheets. By hand, what you would do is you'd order them from least to greatest. And let's say in this example, we have 2, 4, 6, we have 7 data points. If I wanted the 50th percentile, I don't care the value of these numbers. I just care about the location of the numbers. So I'm going to take 50% of 7, which is 3.5. I'll round it to the nearest observation. I'm going to round it up, and I get the 4th observation. So of the data that I see here, 67 would be a value that's in the 50th percentile. Now, 58 to 67, that's kind of rounding up a good amount. So I kind of like Google Sheets a little bit better because they're going to give us a decimal. So they would maybe give us that 64.2 is the 50th percentile. So then I can say, all right, any score above 63.2 or whatever I said would be the 50th or above, or the 50th and below. So we're going to be a little more exact with our percentiles. And so just a brief example, if Sophia took a test and scored in the 79th percentile, she can confirm that she scored equal to or better than 79% of her class, and that 21% scored better than she did. Now, what's not there is what her score was. Maybe she scored a 90 on the test, but 21% of her classmates scored above a 90. So even though she's in the 79th percentile, you might associate that with like a C, so something maybe subpar, but in reality, she did really well on her test. It's just that there just so happened to be other people in her area that scored better than a 90. So there's nothing wrong with being the 79th percentile, depending on what you're referring to. All right, so let's take a look at the notes. And what I have here is a list of calories that are found in vanilla flavored ice cream bars. So I've already ordered them from least to greatest. And the first one, get rid of that so you can see everything. The first one is 111 calories. And the worst one, I guess you could say, it probably tastes the best, is 850 calories. So this has the most calories of a vanilla bar, and that has the least. So the first thing I'm going to do is I'm going to find the mean and the median so I can get a general idea of what these values mean. So I'm going to do equals median, parenthesis, and I'm going to copy the data set. So just like I put on the smartboard, if I want the median, I do equals median data set. So 234, this value right here is going to be considered our median. So any value below 234, theoretically, would be in the bottom 50%, and anything above 234 would be in the top 50%. The mean equals average. Go ahead and click that, enter. 275. Now, in respect to this data set, 275 is going to be right above the median. So for those that argue to count the mean or the median as the actual grade, you'll see that it's actually pretty close. They're really just one value off if that value existed. So anyway, so that's what that's saying. And so it kind of makes sense that if you're the mean, that you are kind of in the middle, and that half the people did do better and half the people did worse. And again, it all kind of depends on the big scheme of things. All right, so how about calculating some percentiles? If I wanted to calculate the 60th percentile, I would type in equals percentile, I copy all the data, and do comma 0.6. So 294 would be the 60th percentile. So if I scored right here, then I would be in the 60th percentile. Now, if we do the way we said that we would do it in the slide, I have 1, 2, 23 values. So if I did 23 times 0.6, I would want the 13.8 data point, or the 14th data point. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. What do you know? So if we did it by what it says on the slide, I'm getting an actual value in my data set, so 294. If I do it theoretically through Google Sheets, I'm getting 294.2. So that's why I'm okay with just using Google Sheets and not the way I have in the slide, because this is actually a little bit more accurate and it's also a little bit easier to find. And then here, I'm going to do the percentile again, but of 95%, comma, 0.95. So 432.8. So there's only 2 scores that would be considered higher than the 95th percentile. And then the 100th percentile, comma, 1. So 850 is actually the maximum value, which would also be the 100th percentile. And I'm sure you can already figure out what would be the 0th percentile. It would be the minimum. So if you scored the minimum score, you'd be in the 0th percentile. Now, where I said earlier that the whole 0 and 100% kind of have an issue, is that if you're in the 0th percentile, that means that you scored the same or higher than 0% of the people. Now, if you scored the same as 0% of the people, that means that no one got the score that you got, including yourself. So you can't get a score that no one got, because then you would be the one person who got that score. So technically, the 0th percentile can't exist because it's not possible for you to score something that no one scored. And then the 100th percentile, saying that you scored equal to or higher than 100% of the people. The issue that people have with that is that sometimes people say, well, you can't score higher than 100%. So therefore it goes against the definition of percentiles. But then there is that whole equal to or greater than. So technically it's equal to. So the 100th percentile is a little more accepted. It's still possible, but the 0th percentile rarely happens. Usually it's in the 1st percentile. But as I said, like when my son was weighed, he was in the 0th percentile, which shouldn't mathematically happen. And then I've been in meetings, like IEP meetings, where people get tested for their speech and their reading and things like that. And the lowest will be the 1st percentile, because what's the point in saying, actually, you're the absolute worst, you're in the 0th percentile. Might as well say, well, you're in the 1st percentile so that you were at the bottom score, but there's something about saying that someone got a 0th percentile that kind of hits home a little bit harder. So it also depends on how you're issuing out the information. So the 0th percentile does exist, just there's some conflict behind it. Anyway, today's a day of tangents. Okay, so now let's talk about the quartiles. Now, quartiles, as I said earlier, are special percentiles. If you consider the umbrella title of a percentile, a type of percentile is a quartile. Kind of like on how we could have all stratified sampling, and then cluster is a specific type of stratified sampling. You can have all the rectangles in the world, and a square is a specific type of rectangle. So a quartile is a percentile, but it's just a unique and special type of percentile. The reason why they exist is because they're used to create box and whisker plots. So since they are essential for box and whisker plot creation, they have been given their own special name. So they divide the data into fourths, and so from the minimum value to the first 25% will be quartile 1. And then from 25% to 50% will lead you to the median, which is quartile 2. And then from the median to 75% will be quartile 3. And then from quartile 3, so 75%, to 100% will lead you to the maximum, which is quartile 4. So you have 4 quarters of percentiles, quartiles. To compute them, you do this. However, we are going to be going into spreadsheets and doing that. The last thing I want to talk about on this slide before I go back to the sheets is the interquartile range. The interquartile range is going to be quartile 3 to quartile 1. The reason why that is being used is that is from the 25th to the 75th percentile, and it's based off the interquartile range that we can adjust to where outliers may be found. So depending on the interquartile range, that's how much we would extend quartile 3 and quartile 1 to have theoretical boundaries, and any value outside of those boundaries would be an outlier. But we're not there yet. So how to compute quartiles. So I'm going to compute quartiles by doing equals quartile, and then we select all of our data, comma 1. So 182 represents the first quartile. So everything below 182 is going to be found below 25%. Now I want to do the second, the third, and the fourth. I'm going to get lazy. I just highlighted what I did here, hit Control C, Control V, and pasted it. Except I'm going to change this now to a 2. Paste it again, change it to a 3, paste it again, whoops. Paste it again, 4. Okay, so now quartile 1 is at 182, quartile 2 is at 234, which is also our median. 330.5 is going to be right around here, so that will be our quartile 3, and then 850 is our quartile 4. So now I know the quartiles, I know my percentiles, I am almost ready to create my box and whisker plot. So let's talk about that box and whisker plot for a little bit. There's going to be 2 ways that you could create a box and whisker plot. The first looks something like this, and usually there's a line in between. The other one looks like this, and there's a line in between. So it's just one's horizontal, one's vertical. It depends how you set up your axes. For some reason, first of all, Google Sheet doesn't call them box and whisker plots. They call them candlestick charts. And with the candlestick charts, they only have them vertically. So we are unable to make a horizontal box and whisker plot using Google Sheets, at least I haven't figured it out yet. If we were using the inspires, depending on how you label your horizontal and vertical axes, you could change it from being a horizontal box and whisker to a vertical one. But Google Sheets seems to be a little bit limited with that for some reason. So what values do we need to create a box and whisker plot? Well, this value right here is going to be the minimum value. So the smallest value, or the 0th percentile, is going to be the first point in our box and whisker plot. When we start the box aspect of the box and whisker, it will start off with quartile 1, which is the 25th percentile. It ends at quartile 3, which is the 75th percentile. So we have a grand total of 50%. Half of our values fall between quartile 1 and quartile 3. Usually the average would also be found in between quartile 1 and quartile 3. So what we're kind of saying is that the numbers that would best represent this data are probably probably found between quartile 1 and quartile 3. If I were to do quartile 3 minus quartile 1, that equals the interquartile range, which is abbreviated IQR. So the interquartile range is just figuring out how many values fall between quartile 1 and quartile 3. This is quartile 2, also known as the median. In our spreadsheets, they don't use the median to create a box and whisker plot, but it's part of it. So I'm not quite sure why Google Sheets excludes it, but it didn't make the cut. And then this one here is going to be quartile 4, or the maximum, or the 100th percentile. So together, these 5 things, the minimum, quartile 1, quartile 2, quartile 3, and the maximum, represent what we call a 5-number summary. So if we were to create a box and whisker by hand, as long as we have these 5 numbers, we could create a box and whisker plot. If we had a box and whisker being vertical, we would have the minimum value here, quartile 1, quartile 2, also known as the median, quartile 3, quartile 4. So it just goes from the least to the greatest. So that's the breakdown of a box and whisker plot. Again, they're useful when you want to see the relative position of your data. So let's see how to do it on Google Sheets. So up here, I have started my table. Now I will warn you with the box and whisker plots, they require 5 columns, but the first column has to be text. So where it says calories, this is the first column that they're going to extract from, and then they only want 4 columns of data after that. If you don't do the word calories, then it's going to tell you that you only have 4 of the 5 columns, and 1 of the columns needs to be text. If you try to do the 5-number summary and text, it says you have too many columns. So it literally only wants the minimum, quartile 1, quartile 3, and the maximum. So we're not going to have that nice line through our box, depending if we had horizontal or vertical, which is too bad. I really like that line. All right, the minimum. I'm going to do equals min. This is where I'm trying to connect my tables. I have a new table right here, and I have this table over here. I want it so that if I were to delete a value here, it will affect my other table. So I want to make them connected. And I do that when I reference the table like so. So my minimum, as I already knew, is 111. Quartile 1, well, that information's right here. So I can just go over here, highlight, do Control C, Control V, and as you can see, if I click on the 182, I didn't just type 182, up in the equation bar, or the function bar, whatever you want to call it, I have the calculation. And then quartile 3, I want the calculation. And now it's connecting my data and the quartile that I want. And then lastly, I'm going to do equals max. And boom. All right, so now I have my 5 columns, my 4 values, and the 1 text column. So I'm going to highlight, and I'm going to insert a chart. And it thinks that I want a histogram. Instead, I want, as I said, a candlestick chart. And now I have my box and whisker plot. So taking a look at it, it looks a little weird. If I was new to box and whisker plots, as some of you may be, I would look at this and say, okay, I have a little bit of value here. I have about the same, if not a little more of the value here. And then I have a lot of value here. So this seems to be where most of the data is falling. That's what this graph looks like to me. It looks like that's a little bit, that's more than it, but this is definitely where all my data falls. Well, let's go back to the concept of quartiles and percentiles. This represents a quarter of all my data. So the number of values that are here is exactly the same as the number of values here. The reason why this is so much shorter is because this represents, again, the spread of the data. So if my quartile 1 is 182 right here, I'm going from 111 to 182. That's the difference of 71 data points. So I am covering 71 values from 111 to 182. If I look from quartile 3, that's going from 330 to 850. 330 to 850 is the difference of about 520, 519 and a half, if you will. So 520 values, it's spread out, versus 71. That's why it's so much longer. It's because I'm only covering 71 values versus 520 values. And then what's going on here? Well, between here and here, this combined is the same number of data points as here and here combined, because this box is worth 50% of my values. So even though it's a pretty small box, it still represents the same number of data points as I do for each whisker combined. So the fact that this looks as skewed as it does, it's making me think that maybe we might have an outlier. So I have to go through and figure out if I have any outliers. Outliers are values that are extremely low or extremely high, and they skew my data. So the box and whisker plot, it's a sketch using the 5-number summary. So again, that's the minimum, the maximum, quartile 1, quartile 3, and then the median or quartile 2. How to determine if there are outliers. So what we need to do is we need to find the interquartile range. Multiply the interquartile range by 1.5, and then that product we are going to subtract from quartile 1 and add to quartile 3. Now this formula is not just made up, there's actually logic behind it. I'm going to get rid of this. So here's the logic behind the whole outlier thing. So if I take the interquartile range, then that should be 50% of the data. Now, if I'm going to multiply that by 1.5, the 1 of 1.5 is 100%, and the 0.5 is 50%. So if I take 1.5 of the interquartile range, I'm taking 150% of how many data points are found in the interquartile range. Well, this already represents 25%. So if I'm going to add the full interquartile range plus 50% more, that means that I am going to be covering again, so 50% is 100 of 100% of the interquartile range is 50% of the data. Half of the interquartile range is going to be 25% of the data. So I'm going to be extending my quartile 3 by 75% of the total data points in the interquartile range. So I've already extended by 25%. So what I'm doing is, I know there's a lot of numbers here, I'm extending my maximum value by 50%, and that's giving it quite the cushion. I am saying that if I have a value that exceeds 75% past the quartile 3, that it's probably going to be an outlier. And it's the same logic with the quartile 1. So the reason why it's 1.5 is, my guess is just because that's a pretty easy number to write of 1.5 opposed to like 1.328. And statisticians decided years ago that that is an adequate amount of leniency before it becomes too much. So they're allowing there to be some extension beyond quartile 3, but eventually enough is enough, and it's either too high or it's too low. So what I'm going to do now is go into the Google Sheets, and I'm going to figure out, well, what are those highest of the high and lowest of the low values that if I were to exceed them, then I would conclude that I have an outlier. So first, I have to figure out the interquartile range. So that's quartile 3 minus quartile 1. I already have the values, so I'm just clicking and using them. I get 148.5. So now the minimum value allowed is quartile 1 minus 1.5 times my interquartile range. So again, quartile 1 over here is 1.5 times 148.5, and I am going to subtract that from my quartile 1, which will give me the absolute lowest value that I could include in my data, negative 40.75. So if I have any vanilla flavored ice cream bar that is less than negative 40.75 calories, it's an outlier and it's gone. This would also mean, by the way, you actually lose weight while eating ice cream. If you were actually able to create that safely, you would be a multi-billionaire. All right, max value allowed in a data set. I'm going to do quartile 3 equals first, of course. Quartile 3 plus 1.5 times, again, my interquartile range. And now this is going to give me my absolute maximum value. So I cannot exceed this number. So if I have a number that is bigger than this, then that number would be considered an outlier. And I'm getting 553.25. So looking at my data set, I do have one value that would be considered an outlier. This one right here is bigger than the 553.25. So I want to get rid of it. It just so happens to be my maximum value. So if I get rid of it here, it will also get rid of it here. It will adjust my other quartiles, and it will affect this graph. So I'm just going to move it off to the side because I don't want to get rid of it, because I want to remember that it's still here. But I do want to delete it from my values so that everything can adjust. Well, what happened as soon as I deleted it, in case you missed it, notice all of these values from the mean, the median, all my percentiles, all my quartiles, even my interquartile range, these values up here, everything changes. Now, you only have to do this once. So if you deleted this and then all of a sudden it went from 553 to 518 and you had a value of 520, you would not need to get rid of it because you already got rid of the outliers from the original information. You don't need to get the outliers away from the outlier box and whisker plot, if that makes sense. So you only have to do this once. Now, most importantly, take a look at our box and whisker plot now. This line is a lot closer to being this line. This line, if you doubled in its length, would be very close to where the box is. Now, I'm not saying that a box and whisker plot will be equal length every single time. I mean, looking here from 182 to 209, that's a difference of 27 values. So that's pretty small. From 111 to 182, that was 71. So 71 values versus 27, it's naturally going to be, I guess it'd be like this, naturally going to be longer and shorter, not because there is a lower value or that one has more than the other. They have the same number of values. It's just showing the spread of values. So if you fell into quartile 2, you would be almost an elite group because to get within quartile 2, you had such a small window of scores to fit in. If you're in quartile 1, that's a pretty big range. Still in quartile 4, we're looking at 316, so about 319 to 439. That's over 100. So again, 120 points difference in this quartile. There's only 27 in here. And in the last one here, you're looking at closer to 70-ish. So quartile 1 and quartile 3 have almost the same range. Quartile 2 is the smallest range, and quartile 4 has the largest range. And now from here, depending on the questions, we could answer those. So if I wanted to know, I don't know, let's say this was a stock, and I wanted to know something about it, I would know that the lower scores will happen as frequently as the quartile 3 scores will. So if these are losing money, let's say, because with stocks there's probably negatives in the minimums and positives in the maximums, that you would have an equal chance of losing the most amount of money as in gaining the least amount of money, I guess you will. And then the one that you lose a little bit of money, that spread happens at kind of the least. And then the one that you would gain the most amount of money has the highest range. So then that means that when you do hit into the 4th quartile, you have a good chance of getting really high values. But if you get into the 1st quartile, it looks like the low values as well. So anyway, so it's just a way that you can kind of analyze it and look at it. So again, so your homework for tonight, I'm asking you to recreate one box and whisker plot and identify the interquartile range. And then the next problem is you're answering some questions based off of 3 box and whisker plots. So all this stuff with the percentiles, the quartiles, the outliers, you do not have to do tonight. You only have to calculate the interquartile range and create a box and whisker plot and then answer a few questions. So I'm going to go here and stop.